Hi there. We're going to go over a problem for the digitals and from the digitals textbook that's good for both digitals and DC students. This problem presents two similar circuits. For the untrained eye, it would be easy to confuse them at first, but they are different. So let's familiarize ourselves with what's presented first. You have the symbol for voltage here, uh, two normally open switches, an LED or light emitting diode, and ground. Um, In electrical schematics, you use a lot of shorthand for components. Switches are S, LEDs are LD, voltage is V, and ground is G and D. In these two particular circuits, the kinds of switches that we have are what are termed normally open switches, which we can see because it's open like this. And that refers to the state they're in if they're not being activated. So if no one's messing with them, these are open. The opposite would be what's called a normally closed switch, which would look like this. Switches will be referred to in schematics by their normal state. What we also see here is that LD1 is linked to only one voltage path, and that's determined by the switch, but it has its own ground. LD2, on the other hand, has its own direct voltage path, but its path to ground is again determined by a switch. Now, an LED has polarity. If you're new to digitals or DC, you've probably only learned so far about resistors, and they have no polarity of their own, but that they take on the polarity of the current. Diodes, on the other hand, which is the family of components that LEDs belong to, have polarity, and that means that for them to turn on, current has to enter through their positive side, aka the anode. You can remember that this side is the anode if you think about this part as looking like an A, a capital A. On the other side, you've got the cathode, which is the negative side, and you can remember that this is the negative side because it resembles a minus sign. So how do we get these LEDs to turn on? Well, this is where we talk about how we can look at circuits as being like the alimentary canal, aka your digestive tract. Not a perfect example because there's actually an endpoint, whereas in the circuit it circulates, but follow me here. Um, so let's think of V as being your mouth and ground as your butthole. To be healthy, what you need what you put into your mouth to go benefit your organs. Let's say the LEDs or any components, and to make their way to your butthole. So in an ideal situation, for example one, we're going to close switch one so that we can complete that path. This was open, now it's closed, and we can get electricity going to go through LD1 and down to ground. Hooray, this is a healthy circuit. However, um, let's say we close switch one and switch two. Well, current likes to follow the path of least resistance, and LEDs do have resistance. So now this is going to go down the quickest route it can get to ground, and what you have here is diarrhea, unfortunately. And so that's not even going to go through your LD1. It's not going to turn on. You're going to get nothing. Boo. Um, on the flip side, if you just close switch two, well, now you have starvation because still nothing's coming in through switch one. So that's not good either. So ideal path here, here, that's great. Now with LD2, we've got the direct path to from voltage, but what we don't have is a direct path to ground. So that's not a complete circuit. What we need to turn LD2 on is for switch 2 to be closed, and now it can complete the path to ground, and LD2 is going to turn on. Hooray! All right, healthy circuit there. Unfortunately, though, if you think of this as being like the first example, just because you're new, and you try closing switch one, what you've got now is constipation because that voltage has nowhere to go, and so you're not going to get anything. LD2 is not going to turn on. It has to go to ground to turn on. And so I hope this helps you understand somewhat about how an electrical path has to work for everything to turn on. Come by the tutoring room for more help because we're your Omies.